Welcome. All right, ladies and gentlemen, this video is going to highlight a couple of application problems. And the first one is going to be one we might want to just double check in class that everybody's feeling comfortable with the calculator portion of things. I'm going to try and go through it here with you. And once again, as is always true, if you would like to stop the video at any time and kind of proceed on your own through some of these questions, you are more than welcome to make that happen. Okay, so the following table shows us some data about the number in millions of unemployed people in the labor force between 1984 and 1995. And I went ahead and, because I didn't want you guys to have to watch me create a scatter plot, I went ahead and created just a quick little scatter plot of the year versus the unemployment in millions. So of course the x-axis was our year, and this x is equal to 0 corresponded to, it says right here that it corresponded to 1980. So then this becomes our 1984. That's kind of where our graph began, and goes to 1995. So what I've done is when I see a table like this, what I start out looking for is the smallest number, which I have kind of hidden here with my pen. But the smallest number right here, 6.7, 6.528, okay? That's our smallest number, so I kind of referenced that at the bottom of my graph. And then this is the largest number, this 9.6. So I referenced that kind of at the top of my graph. One thing that is interesting to me is, in looking at this data, you go from the smallest to the largest in a span of like 1, 2, 3 years, and it has been greater than a span of 3 years that you've been dropping from some high on this part of the data. So even though we're going to force this to be periodic, the period seems a little bit not quite symmetric according to our data, but we're going to give it a shot. Okay, so what I want you to do is you're going to go to your calculator at this time, and this is just a kind of a rough sketch I did just to kind of help us to imagine this being sinusoidal, right? Kind of an unemployment rate that is oscillating. And you're going to go to your calculator and you're going to look for the stat button. Okay, it's right there. You're going to hit the stat button and hit enter for calc, and you're going to, in list 1 and list 2, enter your data. Okay, and as you enter your data, you're going to start with 4, 5, 6, and just kind of go through 15 in this L1 column, so 7, 8, continue on down. And then you can see that I've started putting in the unemployment rate, 8.539, 8.312. So you have this data to enter kind of all the way down. And as soon as you've done that, what you're going to do next, so you might want to pause the video, give yourself some time to get all that data in your calculator. It kind of looks like this in your calculator. It looks like L1, L2, and I'm sorry I don't have a active calculator that this is going to show up in, but you definitely want to be in this area in stat and not in your table. Okay, so super important that you're here. And then after you do that, you're going to go back into the stat button. So you'll kind of get back in here, find stat, click on this again, and this time in your screen, you're going to arrow over when you hit stat 2. Oh, I'm sorry. This needs to be, okay, I misspoke. So this needs to be, this you do an edit first. Sorry, guys. Okay, so back it up. This you're going to do an edit. All right, that's going to be the first opportunity underneath the stat button. Sorry if that threw you completely off. All right, apologies. After you get your table in, that's when you're going to go back in and hit your stat button again. And this time you'll go over to Calc, and you're gonna go all the way down. I think it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, ABC, to a sine regression. Okay. And so when you calculate your sine regression, what you should get, and I'm going to go ahead and write my information in here so we can kind of see how we can use our model to write an equation. Stat calc, all the way down to your sine regression. And we're making sure that when we do this, that our list 1 and list 2 are highlighted. And so this is what I have for my A, B, C, and D values. All right. So I'm ending up with y is equal to, and it looks like a 1 point, I'm going to shorten these just a little bit, 2 sine of, my B value is 0.81, approximately, x, plus my C value, you should have gotten, oops, I'm going to change that to a minus, because my C value is negative 2.22, and then a plus, what are we tagging on at the end here? About a plus 7.77. Okay, 7.8, let's say. Well, one of the things I want you to notice specifically from this equation, and you can use this equation to figure out all the rest of the questions you're going to be asked on a problem like this. Basically, what you're going to be asked to do is put in a new year. For example, maybe you're going to put in the year this was 1995. Maybe you're going to put in 1998 and find out what the unemployment rate was in 1998. Well, if this is 16, 17, 18, right, the number 18 would correspond to 1998 and be thrown in here for X, and you do your solving. Also remember that you can put this into your calculator in y sub 1, and then when it asks for example, during what years the unemployment rate dropped below, let's say, I don't know, 7.3, what you can do, remember, is you can put into y sub 2 that number that you're trying to find, that it's, oh, when is it actually, below this 7.3? And your graphing calculator will do this for you, and you can look for those points of intersection for, what years was that unemployment rate a little bit lower. Okay, and then of course it happens again over here according to our model, and you can go from there. Okay, so that's graphing with the calculator, and I apologize for my misstep earlier. Edit first and then calc after you get your data put into your calculator. You also are going to want to be able to kind of quickly sketch a graph by hand, and it's not that you can't utilize a calculator for this, maybe eventually to check your work and to answer questions, but the initial information that you're given is not enough to do a regression on. So I give you the Ferris wheel problem. Okay, so we have been talking about this idea over the course of our time working on sinusoidal functions. We're going to sketch a graph. The Ferris wheel is 20 meters in diameter. So we're just going to use that information. And again, hey, it is possible to stop the video, see what you can do on this, and then come back just to kind of see how things are going. Okay, 20 meters in diameter and boarded at the 6 o'clock position from a platform that is, okay, that just means people are getting on here at the 6 o'clock position from a platform that is 4 meters above the ground. So that means I have a little 4 meter, oops, does it say meters? Ah, perfect. I should probably use meters then. A little 4 meter gap right there when we think about doing our graph. We do not want our picture to drop below 4. All right, important information. It says at t equals 0, you are in the 3 o'clock position, and ascending. Uh-oh. What does ascending mean? Where's 3 o'clock, right? 3 o'clock is right here. And from 3 o'clock, if you're ascending, you're probably going up this way and around your Ferris wheel, right? Going up, 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 up to the top. Okay, so if that's the case, then right here at my sinusoidal axis, which is going to be right in the middle, we're going to figure out where that's going to be in just a second. That's where I'm starting at time equals 0. And I think this is given in minutes because it tells us that you have 1 revolution every 4 minutes. So that's going to be important. So we're just gathering information here and trying to sketch our graph. So there's a lot of information. I'm going to erase my 3 o'clock just because I don't want that to throw you off. But I know my diameter is going to be 20. So that means my amplitude is going to be 10 as I circle, which means my vertical shift has to be 14, and we'll come up here to the top and make this 24. Okay, how do those numbers look? Those should be looking kind of like what you guys have. I don't know that my Ferris wheel is very symmetric, but we're gonna go for it. Okay, so we have our sketch, right? We know that we're boarding here at the 3 o'clock position. We know that 1, 2, 3, 4. At 4 minutes, it's made 1 revolution. So I know that this is going to go up, it's going to come back down, and it's going to finish 1 revolution in 4 minutes. So I've just marked my graph in terms of minutes here. And I know there's symmetry on this sine function. It's going to be 1, 2, 3. Pretty easy to divide 4 by 4, right? And down we go, and up we go. Okay, so let's look at the information we have. We have our vertical shift, which is 14 meters. We have our amplitude, which is going to be 10 meters. We have a phase shift that we do not have to incorporate unless we're going to write this in terms of cosine, which we can. And if we do, we want a phase shift to the right 1 minute, right, if we're going to write it in terms of cosine. So we'll do both. And then what do we have left? The period. We know the period of the function is 4 minutes, which means our b value is going to be 2 pi divided by 4, or pi over 2. Okay, so let's put this all together and write an equation, and then we can maybe look at this 6.5 minute mark and see what we think is happening. Okay, so for cosine, it's going to be y is equal to 14 plus 10 cosine of pi over 2 x. No phase shift for cosine. Oh, wow. I'm going to have to stop for today. No phase shift for sine. Sorry about that. All right. For cosine, right, if we decide to phase shift 1 minute and start cosine, then it can be y is equal to 14 plus 10 cosine of pi over 2. And we have an x, and it looks like a -1 for that 1 minute. So that's if we're going to start here and do keep going, keep going. Let's keep going here. 5, 6, 7, 8, and just see what we think is going to happen, right, as you continue. With this round the circle that we're going. So if you want to predict your height above the ground when you've been on the wheel for 6.5 minutes, you can actually do that, you know, with your graph. You can make an estimate, right? 6.5 is about here, 6.5 minutes. You could maybe say, oh, I think that's at about I don't know, 9 meters, maybe 10 meters. If you're not sure from your graph, remember you can always take your 6.5 seconds and plug it in for what? That's right, you can take it and plug it in right there for x and actually do your calculation based on your sine or cosine. Don't forget that on all of these applied problems, you want your calculators in radian mode. Super important. All right. And then the first two positive times when your height is 18 meters above the ground, I think the best way to tackle this is to go to your, your 18 meters above the ground, which is right here. You can make your graph. I think the best way to do this, and you guys can do it algebraically, you guys can use your graphing calculator. If you want to estimate based on your graph, great, do that, right? You're going to have sometime in the first minute, it's going to be 18 above the ground. You can find that point of intersection on your graphing calculator by plugging in maybe into y sub 2, 18, and maybe one of these equations into y sub 1 to get you working graphically. Remember to change your window to accommodate your scenario if that's the case. But, I don't mind if you guys take a look and say, oh, I think it's going to be, 25 seconds here, and this looks at like, 2 minutes. We know we're right here at exactly 14, so probably a little bit before 2 minutes. 1 minute, 50 seconds, something like that, to get those first two positive times when your height is 18 meters above the ground. All right, so kind of a lot of discussion through this story problem. I hope that was helpful to you guys, and we'll see you in the next video. All right, take care.